Average. I need one of those for disc golf when my disc goes in the river, so I don't have to get in. I always have a towel in my car. Come on. If you're gonna go out in the universe, you better take your towel.
Yeah, I feel like that's not where it is.
19th all day long. All right, homework is 7782. So, band people. I hope you had a great trip. We did not move forward. We watched documentaries and played games.
Yeah.
Yeah, we played
did the same thing on the trip.
We played games where they ate entire cities with black holes, apparently.
We were the last
Yeah,
one
we
to
were
get
allowed to have
away from
phones.
the assembly, so we were sitting there for like 30 minutes.
And we were allowed to have phones, so I just watched anime.
You too. I watched you.
All right.
No. She
It's
made
okay.
that
Oh,
good.
okay.
Oh.
I got very confused.
You did
he's
not
really
put
weird.
that through
Not
your
even
ear.
questioning.
So,
Ew.
I want to try something because I often with this group overteach, and while like that's good and sometimes like is beneficial, sometimes it's really beneficial for you guys to discovery learn.
What?
And sometimes I work too fast. So, and part of this is I need to run to use the restroom. But this next strategy that we're going into, this completing the square technique, is something that actually for a while kind of eluded me as like a student. So this, if you look it up in your textbook, this is what you're going to find in the back if you look up completing the square. So if I click on that and expand it out. But I kind of want you guys to discover your own way through what they're doing. So I want you to look at 71 and 72 on your own for a minute or two and then be able to discuss with each other. Hey, Jacob, put it away for now. How do we solve those? How do we factor them? How do we figure out their zeros? How do we know how to graph it? And then once you get done with 71, look at 72, and you should start to see, make some realizations. And actually, so that we can have the opportunity to discover, let's do this independent for about a minute or two. Let's just take some time to, on your own, in your own head, write down A and B from 71. Go ahead and look through your solution process, and then start looking at 72. So I would challenge you, since you were going to come in here and try to play the quiet game or whatever you want to say, I wonder if we can just think on our own until I return from running to the restroom real quick. If you want to move on to 73, that's fine, but that kind of lets the cat out of the bag. So I would look at 71 and 72 first and try to see if there's any any of those big light bulb moments. Make sense? Right, I'll be right back. I'm just going to run to the restroom real quick, and then we will dive in. We should be able to get through this lesson with some time for practice work, probably.
Let's figure out A. Yes or no? Yes or yay or nay?
You guys be able to figure out A?
It's not possible.
Wait, A's not possible?
Probably is.
What?
Nothing equals 0.
I can't. Okay, so that's one negative one or something, but I don't know. It could be. Oh, that's. Oh, that's.
I don't know.
I
I don't care.
How? It's probably something like decimal. Like something really.
Oh yeah, Mr. Arthur. That thingy where it's like a bunch of mathematicians on a website, and you could like type in an equation and figure out an answer.
Thank you very much, sir.
That thingy.
No. I want to show you guys something that might blow your mind.
Oh, decimal.
It's not.
No.
It's always doesn't.
Wolfram alpha.
Wow.
So give me your attention for just a minute. Wolfram alpha is I don't even know exactly what to say it is. It's like a calculator, but really it's a database. So if you go to Wolfram Alpha, if you just Google, you'll be able to find it, and you type in anything mathematical. And if you copy paste, sometimes things have to be fixed. So to make it to the second power, we use a caret. That means raised to the power of 2. So if I search this quadratic that we're looking at in our textbook today, whatever, 471a, right? So I type that into here. Wolfram Alpha is going to give me everything it knows about this quadratic. Alternate forms of it, solutions of it, number line solutions of it,
The same thing.
related questions about it.
How would a dog see a pot of what the heck?
Yeah. So, Wolfram Alpha is another tool to put into your toolbox.
Can we look
They
up
are
nuclear
the same
detonations?
So, what you should have maybe, we'll go back to it at the end of class if you guys just want to search random things. What we should have potentially seen as we work through x squared plus 4x plus 1 equal to 0, or x plus 2 squared equal to 3 is what?
They're the same thing.
They're the same thing. Now, what do you mean they're the same thing?
The same equation, just in different forms.
Same equation in different form. So like A is quadratic form, right, because it's equal to 0. And B is in perfect square form, but not equal to 0. It's equal to actually a constant. So solutions in part B would be where does an input of x actually make the output equal 3, right? Whereas solutions in part A are inputs of a certain x make it equal to 0.
What's the square root of 3? I don't know where you got the 3 from.
I don't know. It's what you guys are saying.
What's the square root of 3?
That's what Seaman said. We don't know what he's talking
Square root
about.
of 3. Well, on the other page. So is that 3 minus 12 plus 1?
So if we try to solve A in quadratic form, we need two things that add to 4 that multiply to make 1.
There's nothing that.
It'd be like some.
The only thing that multiplies to 1 would be 1 and 1.
Okay.
Or negative 1 and 1.
Are you sure about that?
What else could multiply to 1? Yeah, but a quarter. 4. You have to deal with you're dealing with whole numbers here.
X doesn't have to be a whole number. Aha!
Is it impossible?
I mean, it's
Not nothing, but there are very, very few things
technically
that are
they're
impossible.
things that are impossible.
So I just this weekend watched Infinity War.
Oh my
I love when Doctor Strange looks into the future and he like plays out all the situations of them fighting Thanos, and they're like, "Well, how many did you look at?" He's like, 14,600,000, like 204, like that. We're like, well, and how many do we win? One. So there's a way to do it. It just might be really complicated. If we look over at B, well, that's the speculation at the end of the movie. So I don't want to for anyone who hasn't seen it, I don't want to talk more about it. But I just love talking about like the 1 in 14 million. But there's still one. Like there's still a chance of it. Like this is how we win. Did you notice as he's dying, he says it was the only way?
Yeah.
Yeah.
And apparently
So-
Spider-Man was completely.
All right. So back on topic. So you're saying, hold on. You're saying A is really difficult and/or potentially "quote unquote" impossible for what we know how to do right now. But B, were you able to solve B?
It'll just you gotta find out the square root of 3.
It's just 1, right?
No, you gotta find out
So
what the square root
what you're
of 3 is.
saying is x plus 2 is the square root of 3.
Yeah.
Which remember, this actually has two options: positive, negative.
And then you make that, and then you subtract 2 from it. So it'll be negative or minus.
Subtract 2 from it. Well, we said properly we would write it the other way around. Negative 2 plus or minus radical 3.
-2.
Stop.
Stop.
Now, I thought of that.
Stop.
I didn't sing that out.
That's called self-control.
And not that part.
Oh, dang.
Alright, so hold on. This idea of taking something unmanageable and making it manageable is called completing the square. So here's what they actually did. A sucks.
Yes, it does.
Right? It's in bad form. Well, not in bad form. It's in quadratic form, a squared or x squared, bx, yada yada. But when we think about multiplying to make 1, adding to make 4, that sounds like nonsense. But algebra tells me I can do whatever the heck I want, as long as I follow the rules. So we know that if I want to use 2, 2 is much easier to add and make 4. I could have x plus 2, get my 4x, but I wouldn't get my 1. So if I want to like break this and make it work more easily, I can just say, well, shoot, if I add 3 over here and I add 3 over here, this actually turns into x squared plus 4x plus 4, which is now a perfect square equation.
Yay!
And that is just x plus 2 squared.
Is there an easy way to determine this perfect square?
But now, because I added 3 on the right, we're now equal to 3 instead of equal to 0. Any questions on how we would go from A to B, straight up algebra, adding 3 on both sides? Yeah?
Is there an easy way to determine perfect square?
Yeah, you're just looking for this second number to be a perfect square, and the B value
I mean, technically,
to be
that is a
double the square root.
It's not double the square root.
Yes, it is.
What's the square root of 4?
Oh, double. Okay.
You fool.
I was thinking of the A value.
So, if you had x squared plus something x plus 9 for this to be perfect square, what would this 6, right? The square root added like 3x and 3x.
Does the quadratic part of it count? Or do anything?
What do you mean?
Like 2x plus 6x
2x.
plus 9.
You mean
2x
the coefficient? Oh, yeah, it would definitely matter.
So, does it always have to have a
It would
coefficient
be
of
the
1?
square root times whatever the coefficient is.
Wait.
So you're going further than we need to go. I like that you're asking those questions, but stop for right now. Okay, you're gonna confuse your brain. So what this does, what this does visually, and we can get out algebra tiles. I was debating whether to have them on your desk when you come in or not, but sometimes you guys just play more than you learn.
I like playing with algebra.
So take a moment, close your mouth, open your eyes, and look at physically what's happening. We have an x squared. we have 4 x's and we have 1 constant, like 1 tile. We don't know what x is, and we don't, then obviously don't know what x squared is, but we do know that they line up, right? An x squared and an x squared and an x. So we know we have some sort of shape that we can line up like this, that we can move one of these x's over if we wanted to, but that this is how it looks best. If we want to make it the easiest way possible, we want that shape, that rectangle, to be a square. So that's why I have a length of x and 2 and a length of x and 2. The only thing that this is missing to be a square, ooh, that's a bad place to put that. My smart board is not lined up.
Wait, so could you do x squared plus 4x plus 1 minus 3 equals negative 3?
You're ahead. Hang on. So we are missing these 3 1 tiles
I mean, negative.
to make a perfect square. If I put those in, I know my dimensions are x plus 2 and x plus 2.
They're not shaded, so they're negative.
So if I put, those don't even exist right now. So if I put them in shaded,
There you go.
these,
Shade you.
then I have to put these in, right? Both sides. I have to follow the algebraic rules. I've made a perfect square, but it's now not equal to 0. So I can solve this real easy, but I'm equal to 3, not 0. So then that's where we do the square root on both sides and we deal with the radical 3. This is what we do with any equation that we want to force into perfect square form. We think about it as it is given to us. How close is it to a square? What is it missing? What do I need to do to both sides? And then I can deal with it from there. Now what we're going to see is some really cool relationships that get formed from here. So this I could write as, so Saki, I think this is going to answer your question, x plus 2 squared minus 3, but that would be equal to 0.
Okay.
Because if I take 3 away from both sides to get it in quadratic form. Now, if I go back to Wolfram Alpha, I want you to pay attention to one thing.
Okay. So someone has the last name.
Will there be a 6? 5.
We may not see it yet. I wonder if we throw this in Desmos, if that might be easier to see.
Who's Desmos?
Desmos just has the grid and everything else.
But it's more gritty.
Stop.
You need more grit.
I think the caret works. Nope. Oh, so in Desmos, if you type the caret, it puts you up into the power. So
Whoa.
What?
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 x squared plus 4x plus 1.
What?
X squared plus 4x plus 1.
You do what?
You can't type it in as equal to 0, guys. If you type it in equal to 0, that screws up your graph. So you either just type in the function, or you have to type it equal to y. Remember, when we say equal to 0, that's actually solving like the algebra of when is it equal to 0. We're
Those
finding.
So the 2 lines it had, that was
X,
where
the zeros.
Mhm. Those are the x values that made it equal to 0. So guys, if I type equal to 0, all it does is give me vertical lines at those
That's
x's.
Useful. That's nice. Now we know.
Do they ever connect?
Dude, it's just
Parallel
vertical
lines.
lines. They're both vertical. Now hold on.
Sure.
Wait a minute. Put a little. No.
What?
Hold up. Wait a minute.
Oh,
I forget what. So
There's
I
a
told you to.
-2 and a 3 there.
What, Chris?
Ah!
There's a what?
Vertex is at -2 and it's So I mean,
Oh, there we go.
Wait. So
Feigning surprise.
if we wait, so I took this perfect square equation, which is this equation, right? Because I graphed that equation, the original.
It just goes down 3.
Yeah.
So oh, okay, so that's just vertical change, right? Okay, down 3. That's not really a big surprise. But then the 2.
Oh, that makes sense.
Yeah, because
Wait, let's test this. Let's try this out. So hold on. Look at 74. Write down x squared plus 6x plus 5 in your paper, please.
X squared plus 6x plus
4.
5.
Now, the rule we have to follow. The rule we have to follow is split your x's in half so that it is as close to a square as possible. Right, so I can't put 4 x's on one side and 2 x's on the other because then I'm not close to a square. And I cannot, because this is the question that's been asked before, I cannot put 1 tiles here to end up equaling an amount of x because x would then have to be countable. X is not countable. So I can only line up my 1 tiles at a 1, 1. Like this is 1, this is 1. That's why I can fit a 1 tile there. I cannot put 1 tiles up here because I can't count x. Likewise, I cannot put 1 tiles out here or over there or wherever. Can't line them up with x. How far off of being a perfect square is this?
4.
4. So let's just add 4 to both sides. If we add 4 to both sides,
Perfect square.
good, they're possible. Now, what are the dimensions of that square?
X plus 3.
X plus 3
squared. Minus 4. Oh, equals minus 4.
No, just equals 4.
Okay.
Think about it. And this is why we're doing this. We made it a perfect square, which means the dimensions are now x plus 3 squared. It wasn't before, right? It did not have all this space, but now this is equal to 4. So if I want to put it back in quadratic form, I would have x plus 3 squared minus 4 equals 0, which would tell me what?
The y point of the vertex. Having trouble there, Chris? I can't.
English.
I cannot use
Oh,
my
negative 4.
No, negative.
Make sure we're all with us. So, as we saw when we went over here with Desmos, we had x plus 2 minus 3. Right? This was the equation that we had over here. Sorry, x plus 2 minus 3. My 0 was negative. I know, it's driving me crazy too, so give me a second. If we compare this with our current one we're looking at, what's the vertex?
Negative 3. Minus 3. Negative 3.
The opposite of what's in here. Please write that down. And we know the zeros. Because as we talked about with part B up there that we solved, if I think about it in this form and take the square root of both sides, what we would then have is x plus 3 equals radical 4, right? Which is plus or minus. So then my zeros
That's radical, bro.
actually, I can just write them both together, right? My zeros are when x equals negative 3 plus or minus radical 4. Yeah, so I could write it like that, but because radical 4 is so nice, we could say what that really means is, okay, negative 3 plus 2, negative 1, and negative 3 minus 2, negative 5. which makes sense that my vertex falls between them. So we have some verification that my vertex needs to be there. Guys, we already have 3 points of the parabola.
Wasn't that useful?
Taking this and making it, you know what other 2 points I would do?
Wait, and then
X is negative
find
4.
out the y-intercept too?
Hmm?
Can you find out the y-intercept? 'Cause
What's the y-intercept?
Wouldn't it be like 5? Or wait,
No,
because
would it be?
If we add something to both sides, does it actually change what we have? We follow the algebraic rules, and we added 4 to both sides. Does it actually change the graph if I do something to both sides?
No.
No. So if I think about this
Add
graph
something.
originally, what's the 0 there? Or, sorry, the y-intercept.
Should be 5.
Y-intercept's 5. So we should also have a point of 0, 5. If I plug this into Desmos, because this is why we do completing the square. It's a process that a lot of people dislike at the beginning, but x squared plus, what do we have, 6x plus 5?
4. Then 1
Y-intercept at 5. My zeros, negative 5, negative 1. My vertex, crap, when you change the zoom, you lose your points. My vertex, negative 3, negative 4. We found all 4 of these points just based off our equation.
Looks like a
Then this point, that is our y-intercept, can be reflected, and we have a 5th point.
there's
Well, yeah, if I can lock it in somewhere.
right there.
It looks really straight.
I can't lock, unless it's connected enough. So if I make a line of y equals 5, then I can connect it and show that. Once it is an intersection, then Desmos will let the point actually show up. And then we can graph it.
Woo.
Real easy. So try that.
What's he doing now?
So this has been a thing for weeks. We've been giving him just because he has no
Lauren, you have to-
Why are you over there? Don't be over there. Try it with B. But B starts with x squared. Hey, B's different form. B uses negatives. You should be excited about this, Jacob.
Yeah.
B starts with x squared plus 2x minus 5.
So when you take the square, do we include
Shh, try it on your own first. I don't want to answer questions. Try it on your own first. Okay, I don't know what is going on with my ink capture today, but it is.
Would you add
not
5 or 6
functioning.
each side?
I'll fix you, fool.
What?
We already start knowing a point. Graph this. If you're done, you should be able to graph it. You should be able to find 5 points that let you graph this. There's 1 point given to us right off the bat. 0, negative 5. I think I heard people say add 6 on both sides.
You get 1. I think I've got them. Can I take again as to what they are?
What do you mean red? You can help me get there. What would I have now?
You would have x plus 1 squared 6, and then make that x plus 1 squared equals minus 6, 0. And then over here, the vertex is negative 1, negative 6. And then, yeah, the opposite of the y-intercept is equal to negative 5. And the zeros are, I believe, 0 and negative 2. Is that right?
0, negative 2.
How did you get
How did you get
negative? How did
Did
you
you
get
get
Hold on. Just let's get what Chris has, and then we'll figure out if it's right, wrong, or where we're at.
0 and negative 2.
So you said zeros. If we from here do the square root and then subtract the 1, we have negative 1, right? Plus or minus radical 6. Radical 6 is not a perfect square, so I would just leave it as the radical form.
What's it close to?
So that's 2 points.
Yeah.
Knowing that the vertex is at negative 1, I reflect it to negative 2. So I have 1, 2, 3, 4, 5. We should be able to graph this. Now, if you are manually making the graph, figure out what the decimal approximation of this is. It's between 2 and 3, right? Because it's between 4 and 9. We can take, have I ever taught you guys the Rachel method of approximating radicals? Okay, so Rachel was a student years ago who thought up an amazing system for approximating radicals in my class. She asked the question of, does this work? And we tested it, and it works pretty darn well. So 6 is between what two perfect squares?
2 and 3.
Well, yeah, 4 and 9, right? Because 4 and 9 are the perfect squares. 2 and 3 are the roots of those perfect squares. What's the distance between 4 and 9? 5. Where does 6 fall in that distance?
Above.
How far up into it? 2, right? It's approximately 2/5 of the way to the next perfect square. Now, this works better in the bigger gaps, but if you do square root of 6, what do you get? Like, look, try. I bet you it's close to 2.4. Because 0.4 is 2/5 of the distance.
Oh my gosh.
That is a rational approximation of radicals. So, if you had a radical, hold on, if you have like radical, let's say 19. Radical 19 is between what two perfect squares? 16 and 25. What's that distance? 9, right? Radical 19 is how much of it? 3, right? Do radical 19.
Somewhere around
4.35 instead of 4.33, 4.35. It's normally accurate at least to the 10th place, sometimes to the 100th place. So if you need to, and if you don't have a calculator and you need to approximate, you can use that method. Let's try this some
that
more.
needs to be patented.
Yeah.
I bet you there is some formalized method, but again, it only works to approximate. It does not like
No, I know. But
100% work out all the time.
the tried and true, your calculators in your backpack and your too lazy to go get?
Yes, exactly. So look at 75. Without the visuals, decide in 75, what do we need to do to these to get them into So really, all I want you to be able to do here is tell me what the vertex is without graphing it and without actually solving it, like without finding the zero. I just want you to be able to quickly get to the vertex. So take a moment on your own, try to figure out what do we need to do to these to get them into perfect square form by relating the b. Now, so if you notice, right now we're starting with no a values aside from 1. We're going to start you guys out with all a values of 1 to get comfortable with this. x is my b value, what should my c be to make it perfect?
4,
Also 4, which means what do we need to add to both sides?
9.
So we end up with x plus 2 squared equals 9, which means the vertex would be
Negative 2.
negative 2, negative 9. Here's the really easy trick. Once you get it in perfect square form, opposite, opposite.
What's the V for?
Vertex. Like V is at, the vertex is.
And then what about B?
So B, if my middle term is negative 6, and I think about what squared will make that, what should this constant be? Minus 3, right? So what does that mean my C should be?
9? Negative 9? Plus
Not negative, positive 9, right? This needs to be positive 9, which means what do I need to actually add to both sides?
10. Oh, 10.
10.
That's negative.
So we're
Here's, hey, honest truth time. Here's what I couldn't figure out in high school. I kept getting stuck on the actual perfect square that I was trying to get to. But that's not what we add on both sides. That's what I'm trying to get my equation to be. So to make this be negative 6x plus 9, I must add 10 from the negative 1 to get to positive 9. Now, the other method that helps with students like me that can't figure this out, make this 0 at first. So first, I get rid of the negative 1, and I literally just make my equation x squared plus 6x equal to 1. Sorry, minus 6x. Then I say, well, this doesn't have any c at all. What should my c be? Okay, positive 9. So what do? I add 9 to both sides, which is what I ended up having to do for a while in high school till it like clicked with me, which makes my constant over here become 10.
Isn't that basically what we're doing?
Yes, but I had issues with this in high school, so I like to teach you guys and this is one technique that they do teach. Get rid of the constant on the left side and then determine what you want it to be to perfectly fit into perfect square. So this then becomes minus 3. That's going to drive me crazy. Equals 10, which means your vertex, positive 3, negative 10.
Don't draw your V's like that, because then it looks like the square root of 3.
It kind of looks like a square root, but it's
It looks
not.
like a square
Isn't
root.
it what? So are we good with this?
Yeah.
Not over V's.
So then C,
1 negative 5.
I don't want that actually. Get out of here. This isn't working today. I don't know why my smart ink is being so weird.
Wait. So it's double the root.
So then
We're going to want
to
that
add to
36.
negative 2,
You add 4.
I'm going to want x minus 1.
Oh, there's
Right?
one there.
So what does that mean my constant would need to be?
So 1.
Plus 1, right? To actually make it be x minus 1 squared?
Plus 3.
Mm.
You'd add 3 to both sides.
No! Because there's 1 on that
We
side.
need to get to positive 1. We need to add 4.
Oh, but there's a 1 on the other
That's
side.
Doesn't matter.
Oh,
Does not matter.
Hold on. Never mind.
So once I do that, I have x minus 1 squared, but equal to what? 5.
So it'd be plus 1 and minus 5.
Which means our vertex is at 1, negative 5. Questions? Now, the extension of this. If we think about 76,
No, skip one.
It should be plus 33, right?
now we have x squared plus 12x plus 3 equals 11.
So it should be 2x squared plus 12x plus 33 equals 44, right?
But
It's not.
Yeah.
2x squared.
But then we can divide it all by 2.
Plus 36. You couldn't divide it all by
And
2.
then we get x
Yeah,
squared.
actually, no, you could.
It has to be 9.
Plus 6.
You need where's the 6? Yeah, you need to add 6 to both sides.
It's the revenge of the 6.
Because there's a 2
But
across
how's that gonna make a perfect square?
There's a 2 across the x square.
Yeah? I mean, so how's that gonna make a perfect square? Like visually.
Oh, we should make it 18. We add 15 each side.
No.
We divide it by 2, and then we have 2x plus 6x plus 9.
What are you doing?
Or x squared plus 6x. That's not right.
The square root of 18 is not going to make.
No, because we're dividing it out by 2. To get rid of the 2x.
Oh, that's what you're trying to do. You're trying to
Can I come up for a second?
Okay.
Why would
So, I imagine this is a little bit of a problem and it'd be easier to solve without it, right?
I don't know.
So,
Just
to do that, we should add 15
oh,
to
that's,
this
that kind of makes sense.
and make it 18 and then divide it all by 2. There we go, that's perfect. And
that's
then,
the good stuff.
and then we've got x squared plus,
Oh, yeah.
What is that?
plus 9 equals 12 and a half.
Except, yeah, no. That's right.
Or no, wait, that's wrong. That's
So-
that's 13.
Here's what I was debating whether we actually like let out today or not.
And then we've got
If you have 2x squared, and I don't think I have a picture of it ready. I do
I
not.
want to do it.
and the vertex should be
Now be careful, even if we factor out the 2, we would still write it over there,
Wait, what?
right? So that we don't actually, yeah, unless we somehow do it on both sides legitimately and then it's gone. But we don't want to actually change this equation, right? We want to keep all the pieces of it. So we would write 2x plus 3 squared, because the reason behind this, I can't make a perfect square involving 2x squareds. It's going to be rectangular. I could make 2 perfect squares out of 2x squared and go from there. So my 2 perfect squares will have dimensions of x plus 3. We're going to pick this up when we come back from break. We're going to review completing the square because it will probably drift back into your memory and not be as useful. We're going to review this all next Monday, and then we'll keep moving forward. Okay? Have a wonderful Thanksgiving break. Eat lots of good food. Good luck with bowling tomorrow.
Are you going bowling
Of course, we're all going
Oh,
bowling.
yeah. Are you on a team
Group
yet?
activity.
Are you on a team?
No, I have not. We won't sign up till late. We normally just take like a teacher lane or fill in where needed.